Hello, everyone. This is Haiding Tian, your Math 1316 Trigonometry instructor. This semester, we're learning the trigonometry together. This is a very fun and useful subject. This video, we are learning chapter 1.1, angles. First, let's see the definition of angle. A figure which is formed by two rays or lines that shares a common endpoint is called angle. We must have an endpoint, and then starting from the endpoint, or we call this vertex, we have a ray or a line. Then we have another ray, that's a straight line. So between them, we call this angle. So we always say one side is initial side, and then we do the rotation, get another side. We call that terminal side. So the angle between them, sometimes we say this is theta, sometimes we say that's alpha. Now we see we must have a vertex, we must have a terminal side, we must have a rotation, and we have a terminal side. So the angle between these two rays, the theta is the angle between these two rays. All right, let's see standard position. We can move our angle to the XY plane. We have learned the XY plane in college algebra. So we can put our initial side to the positive x-axis. So this one is the initial side. And then we do the counterclockwise rotation. Then we got to we found our terminal side here. And the alpha is the angle is formed by the initial side and the terminal side. The vertex, so the vertex in previous two examples here, we put it at the origin of the XY plane. All right, let's see. If here we have the XY plane, for example, this is the x-axis, this is the y-axis. Then I'm doing the counterclockwise rotation. You see the pink, we're starting from initial side, the positive x-axis, then all the way rotate counterclockwise, stop here. So this one we call positive angle. If we rotate opposite way, the clockwise rotation, we call that negative angle. So we are starting from the initial side and rotate this way, clockwise. We got the terminal side, CB. So this one we call negative angle. All right, let's see next 4 examples. Acute angle. Acute angle is the angle between 0 and 90 degrees. Right angle. Right angle is the angle theta equals 90 degrees. Sometimes we use different symbol. We use alpha, we use beta, gamma, represent the angle. Next one is obtuse angle. The angle is between 90 degree and 180 degree. Next angle we call the straight angle. That's the theta equals 180 degree. All right. So if I have the XY plane and my initial side is here, if I have a ray here, this is my vertex, I will rotate counterclockwise this way and then all the way back. All right, can you tell me what is the degree or what is the measure of the angle theta? That's a full rotation or one full rotation. Theta equals 360. That means one full rotation is 360 and the half, so from here to here is 180 and 1/4 of the full rotation, that's theta equals 90 degree. All right, let's see, next angle is 45 degree. starting from initial side, positive x-axis, stop here. So angle is 45 degree. And next one is negative angle. That's starting from the initial side and rotate clockwise. So that's negative 270 degree. Next one, 30 degree. Next one, we rotate clockwise. So that's a negative angle, negative 150. Next, we will see two definitions, complementary angles and supplementary angles. Complementary, that means if I have two angles, alpha, beta, the sum of these two angles, I got 90 degree. So alpha and beta are complementary. If alpha plus beta equals 180 degree, we say alpha and beta are supplementary. So these two definitions confuse me a little bit because sometimes I don't know which one is complementary, which one is supplementary. But in alphabet, so C comes first. So that means complementary, C comes first. C comes first, that means the sum of two equals 90, the small number or small angle. And S, that's the, in alphabet is bigger than C, comes later. So that means two angles, the sum equals 180. All right. Example one, find complementary and supplementary of following angles. Number 8, we have 48 degree. So for example, we call this theta, and then what is the theta prime? Use another symbol represent a complementary, or we say, use this. So complementary. So complementary means alpha plus beta equals 90. So the complementary of 48, that means use 90 degree, subtract 48 degree. That is the complementary of 48. So we know this one, we say this is alpha. I'm looking for its beta. So use 90 minus alpha. What is this? So 42 degree. How about supplementary? Supplementary, so alpha plus beta equals 180. Now alpha equals 48. So beta equals 180 degree minus 48. So that's 2, so 3, so 132. All right, you can pause the video and do the number B. What is the complementary of 77 degree? So alpha equals 77. What is the beta? So complementary, the beta equals 90 minus 77. So that is 13. So how about the supplementary? That's 180 degree minus 77. That is 103 degree. All right. Let's see. We say the degree is the unit of the angle. What's the meaning of that? So if I have one full rotation, I start from the initial to the terminal. So the one full rotation come back to the initial here. So I divide the one full rotation into the 360 parts. So one part or each part is 1 degree. So for example, I cut it into 360 parts. One portion, this one we call it 1 degree. And I can continue to break down the 1 degree into the small portions. So we say next unit, we call it minute. 1 degree divided into 60 parts. So 1 degree equals 60 minutes. One part is 1 minute. Next one is second. 1 minute equals 60 seconds. Oh, that means, for example, I say this one is 1 degree. So it's one portion from 360, the full rotation, and then divide it into small pieces and divide it into 60 parts. So one part is 1 minute. And then I continue to divide the 1 minute into 60 parts. So one part is 1 second. So 1 minute equals 60 seconds. So let's see what's the relationship between degree, minute, and second. We are having a relationship. 1 degree equals 60 minutes equals 3,600 seconds. And for example, if I have 2 degree, I want to convert it to the minute. So from the big unit to the small unit, I need to increase my number 2. So 2 times 60 minutes. If I continue to convert this one to second, so from the big unit to the small unit, and I need to multiply by 3600. All right, let's see. If I want to convert the 1 minute to degree, so doing the backward one. So from the small unit to the big unit, so the number decreased. I need to divide it by 60. So for example, if I have 2 minutes, I need to convert it to degree. So the 2 need to divide it by 60, and then that's the degree. How about 1 second? 1 second converted to the a little bit bigger unit. I need to divide by 60, and then convert it to the big unit, degree. I need to divide it by 3,600. All right, let's do some practice. Exam 2. If I want to add 2 angles together. So for example, if I have one angle and I have another angle, so if I want to add these 2 angles, so I'm having a big angle. So just to add them straightforwardly. So I can add the degrees together. I can add the minutes together. So I have 51 plus 32. This is a degree. Plus 29 plus 46 minutes. So look at here. I add the minutes together. Oh, sorry. Degree together. And then I add the minutes together. Let's see. 51 plus 32, that's 83 degree, plus 29 plus 46, that's 75 minutes. But I know that 60 minutes equals 1 degree. So 75, that's a big number in minutes. I can convert it to degree. So I know that. So bring the 83 down. I know that 75 equals 60 minutes plus 15 minutes. And this represents 1 degree. So 83 degree plus 1 degree plus 15 minutes. I'm having So degree plus degree, 84. Then 15. So if I have plus, I can ignore the plus and then stick the degree and the minutes together. How about next one? Do the subtraction between two angles. So degree minus degree and minutes minus minutes. Let's see. The first number doesn't have a minutes, but the second angle has minutes. How should I subtract the minutes for the second minutes from the first minute? I can borrow one because here, the notes, 60 minutes equals 1 degree. I can borrow 1 degree from 90. So I'm having 89 degree, 60 minutes. So they are equal. They're equal. 90 degree equals 89 degree, 60 minutes. And then now I can do the degree minus degree, minutes minus minutes. So use 89 minus 73 degree. And then here is a plus because you already do the subtraction between the degree. So you cannot bring this, so let me use different color. So this minus sign comes here and then plus 60 minus 12. This is the minutes. So you have your minus here, here, and here. Let's do the computation. 89 minus 73, I'm having 16. That's a degree. Plus 60 minus 12, that's 48. That's minute. So now I can combine the degree and the minutes together. I can ignore the plus sign. So I have 16 degree, 48 minutes. All right, let's see. Example 3. Convert the one angle to decimal degrees. Round to 4 decimal places. This question, we want to get rid of the minutes because we only want the degrees. So convert only the 30 minutes to the degree. So let's separate the degree and the minutes. So 124 degree, 30 minutes, that equals 124 degree plus 30 minutes. I only want to convert this part to be the degrees. So 124 degree plus from the small unit to the big unit degree. What should I do? I should use 30 divided by 60. All right, let's do the computation. 125 degree plus 30 over 60, that's 0.5. Then add them together, I have 125.5 degree. So round to 4 decimal places. I don't have too many decimals, but I can put zeros to make a 4 decimal places. 125.5000. So I have 4 decimal places. These are 4 decimal places. Put a degree here. All right, number B. Convert this one to decimal degrees. Round to 4 decimal places. That means I cannot have a minute. I cannot have this second. So I can keep the 74 degree. First step, let's break down this angle into 74 degree plus 42. What happened to my pen? 42 minutes plus 15 seconds. I need to convert this one first. From the minute to degree, we need to divide it by 60. And then from the second to degree, divided by 3600. All right, let's use the calculator to do the computation. Okay. 42 divided by 60, so that's 0.7 degree. How about 15 divided by 3600? So I get 0.0041666. Yeah, maybe. Plus 1 is 7. So if I want to add them together, that's 74.7, because I need to add them together. And then, so add them together. Don't forget there's a degree here. So 7 covered this. So we have a 0.0416666. So let's put a 7 here. So keep 4 decimal places. So keep 4. The 5th digit is 6. 6 is greater than or equal to 5. That means I need to add 1 to the previous digit. I'm having 74.7042 degree. All right, let's see number 4. Example 4. Convert the angle to degree minute second, DMS form. That means my angle must have a degree, must have a minute and a second part. So we already have the degree. I can convert the decimal part to the minute second. All right, let's do this. So first step, I'm going to separate the integers and the decimals. So 15.2 degrees equals 15 degrees plus 0.2 degrees. 15 is a degree, is the integer, so I just leave it there. But the decimals, 0.2, I can convert it to the minutes first, because I know that from the degree, the big unit to the small unit, the number increased. So 0.2 multiplied by 60. Then we have 15 degree plus 0.2 times 60. That's 12 minutes. So combine them together, I'm having 15 degree, 12 minutes. All right, we have no decimals. That means I don't need to convert it to second. If we still have the decimal, let's keep on convert the decimals to second. Next one, let's break down this number, this angle, into the integers and decimals. I'm having 159 degree plus 0.26 degree. So 159 degrees plus, from the degree to minutes, what should I do? 0.26 multiply by what? Or divided by what? Multiply by 60. 159 degrees plus, I must use my calculator, 0.26 times 60. I have 15.6 minutes. We have a decimal again. So I need to convert the decimal 0.6 minutes to second. 159 degrees plus 15. 15 minutes plus 0.6. This is the minute. 159 degrees plus 15 minutes plus, from the minute to second. What should I do? So from the big unit to the small unit, I'm going to multiply 0.6 times 60 because I only from the minute to second, I multiply by 60. If I have from the degree to the second, multiply by 3600. All right, let's do the computation this part. Let's move this to the top. 159 degrees plus 15 minutes plus, so 6 times 6, 36. This is the second. So combine them together because they are all integers. So 159 degrees, 15 minutes, 36 seconds. All right, if you think it's not useful here, I can erase it. All right, let's see. Next part is the determine terminal angle. What is a coterminal angles? So this is the definition. Two angles with the same initial side and the same terminal side are called the coterminal angles. For example, if in the standard position, I have angle starting from initial here and then stop here at the terminal, and I got the angle is 30 degrees. Coterminal, the definition is they have the same initial side and the same terminal side, but the angle is different. For example, I rotate from the initial side to terminal side and make a 30, and then I didn't stop at all. So I do the rotation. I didn't stop here. I continue to rotate and then all the way back here. Okay, so look at the blue ray. So the red and blue, they have the same initial and they have the same terminal, but the angle, they are different. So if I have the angle 390 degree, that means based on the 30, I did one more rotation and 30 degree 30 and the angle 30 and the angle 390, they have the same initial and same terminal. So 30 and 390, they are coterminal angles. And based on the 30 degrees, I do another two rotations plus 2 times 360 degrees. I got 750 degrees. And 750, they are called terminals. So I did 2 more rotations. How about 30? And then I do a clockwise rotation. I rotate to the opposite direction, plus negative 360. I'm having a negative 330 degrees. So 30 and negative 330, they are also the coterminal angles. All right, here we have a formula for the coterminal angle. If I have an angle alpha, for example, in previous example, my alpha equals 30 degrees. So I plus or minus n times 360 degrees. This is the coterminal angle of the alpha. For example, I can have 30 plus 360 or 30 minus 360, or 30 degrees plus 2 times 360 degrees. So n could be any natural number 1, 2, 3, 4. All right, example 6. Let's find the coterminal angle. So let's find the coterminal angle on this interval between 0 to 360 degrees. So if I have a theta equals 40 degrees, I know that coterminal means I plus 360 minus 360. I'm having coterminal angles of 440 degrees. But if I plus 360, I'm not having an angle that's in this interval between 0 and 360. That means I can subtract 360. Then my angle could be in this interval. So let's see what is let's say theta prime is the coterminal angle of theta equals 440 minus 360. I got 80 degrees. So 80 degree, it is in the interval from 0 to 360. So this is the one coterminal angle of the theta in that interval. How about number B? Theta equals 960 degree is coterminal. Because this is a big angle, I can subtract one rotation. Or if I subtract one rotation is not in the interval, I can subtract 2 rotations. So 960, that's a big number or big angle. Let's try to subtract 2 times 360 degrees. This is multiplication. We have 960 minus 72 degrees. I'm having 240 degrees. Yes, this is in the interval. All right, how about next example? Theta equals negative 225 degrees. This is a negative angle. If I want to find its coterminal, theta prime, I must have an angle between 0 and 360. Let's add negative 225 degrees plus 1 full rotation. If it's very negative, a big negative number, so I need to add more rotations. All right, let's see, what is that? 6 minus 2 is 3, and 3 minus 2 is 1. So we got 135 degrees. All right, let's see number 7. My cheat sheet. Yes, there's no mistake. Example 7, number A. The angle A, I can put an angle A equals 260 degrees. The measure of the least positive coterminal angle is. What's the meaning of least positive coterminal? I know the positive coterminal. Least means the smallest. Oh, based on the angle A, 260 degrees, I can add 1 full rotation, 360. That's the smallest positive coterminal. So I can say A prime equals 260 plus 360. What is that? That's 620 degrees. This is the least positive coterminal. All right, number B. If my angle A equals negative 165 degrees, the measure of the least positive coterminal angle is. All right, I must have a positive coterminal, and that positive coterminal angle is the smallest one. Okay, how about I add 1 full rotation? Can I get a positive angle? Yes, we can. So negative 165 degrees plus 360. Only 1 full rotation can get a positive coterminal, and also that's the smallest one. All right, let's do the computation. That's 195. All right, we're done for the 1.1. If you have any question, please let me know. All right, have a good one. Bye.